Good morning to all students. I welcome you to the class of Cow and DS. In last class, we were seeing the division methods, okay, for unsigned integer. So first algorithm that we have seen is restoring division algorithm, right? And there we were going for restoring the value of the accumulator. That is why it is named as restoring division algorithm. In today's class, we are going to see another algorithm which is nothing but non-restoring division algorithm. So again, it is used for division of the numbers. Okay, like in last class, we have taken one example, one as dividend and divisor, and we were checking the value of the quotient and remainder. Okay, here also we are going to perform the same thing, but it will be non-restoring. That means the step, okay, where you were taking the accumulator value, you are restoring back. Okay, so that will be not possible in this case. It is as it is named as non-restoring. Okay, so when we see one example, you'll come to know. Okay, can you see the flow chart? Yes, students?
Yes, ma'am.
Yes, ma'am.
Right. So see, in flowchart, again, we are going to start with the problem, okay? And we have initialized the variables that we are using. N is nothing but the number of bits, right? M is the divisor, as we have taken in the last time also. A is the accumulator content, which is initially 0, it has been given. And value of Q is nothing but it is the dividend value, okay. And after that we are going to check the sign bit of A. Okay, so what is the sign bit of A? That is the MSB bit of A. Okay, if the MSB bit of A is 0, okay, so we are going to perform shift left AQ. Okay, we are going to perform shift left with whom? A and Q both. And also we are performing A equals to A minus M, and the result will store in the A, right? If the MSB bit of A is 1 or sign bit of A is 1, what we are going to do? Again, we are going for the shift left of AQ, but here after performing shift left AQ, we are going to perform A equals to A plus M, and result is again stored in A, right? Do you remember last time in restoring, we are going to perform here restore. Okay, when Q0, we are replacing the value of Q0 with the 0 and restoring the value of A. Okay, so that is not possible in this case as it is non-restoring. So after performing this shift left, what we are going to perform? Again, we are going to check the sign bit of A. Is that okay? Again, we are going to check the sign bit of A. That is the MSB bit of A. If again it is 0, okay, so we are replacing the value of Q0 with 1. And if the value of sign bit of A, that is the MSB bit of A is 1, so we are replacing the value of Q0 with 0. Is that okay? After that,
Yes,
we are
ma'am.
going to decrement the value of N. Okay, after this what we are going to do? We are going to perform this condition. What is the condition? We are going to check this condition. If the N is equals to 0, okay, what we are going to do? Okay, first check if N is not equal to 0, again the loop will go on continuing. Is that okay? The same process will go on continuing until N is equal to 0. When N is equals to 0, so we are going to check again the sign bit of A. Okay, again the MSB bit of A we are going to check. If it is 1, so we are going to perform A equals to A plus M. And if it is equals to 0, then directly your quotient is in Q and remainder is in A. Okay, it is. So your quotient will be in Q and remainder will be A, and that is the end of the problem. And when it is equal to 1, again you are going to perform A equals to A plus M. And again the same step, quotient is only one step extra you have to perform here. Is that okay?
Yes,
Yes?
ma'am.
Let us take one simple example so that you can understand that how this is particularly going to perform. Okay, so let me solve the same problem that we have taken by using restoring. The same problem we are going to take by the non-restoring also. Okay, so 11 divided by 3, where 11 is your dividend. And 3 is your divisor. And you know very well, when we divide 11 by 3, what we are going to get? We are going to get 3 as a quotient. Yes?
Yes,
And
ma'am.
Yes.
2 as remainder. So this is normal division. When you perform 11 by 3, you must get this result. So let us check this by performing this non-restoring. So initially we are going to take the values of n, okay, value of m, then a, and the value of q, and operation that you are performing. Operation or whatever the action you are going to take. From the flow chart, you can decide that what is to be performed. So you know very well what is the value of m, divisor. Divisor is nothing but three, and q is your dividend. So q is nothing but
11.
11, right? So I'm going to write here value of q first. That is 1011. Right? That means n is 4, and 4 plus 1 you take as the m bit. Okay, whatever the bits are there for q, plus 1 bits you add to your m and a. So your m is 3. 3 I can write is like this, 0, 0, 0, 1, 1. And a, initially it is 0. In 5 bits I am writing this. So this is the initialization step. This one we have done. Yes. After this, what we are going to check? We are going to check the sign bit of A. Can you see the flowchart? From flowchart, you can perform this. Sign bit of A. What is the sign bit of A? The MSB bit of A.
0.
0. When it is 0, what we have to do? Shift left the value of A and Q. So I am going to perform here. Shift left AQ. So what will be my steps? Okay, left shift you have to perform. Okay, so this will be 0, 0, 0, okay, 0, and this one will be placed here. Yes, again 0, 1, 1, and the value is not available with us. That is why it is question mark. Is that okay? After performing shift left AQ, what we are going to do? A equals to A minus M. Okay, if M is 3, what is your minus M? Yes. If M is 3, what is your minus M? 0, 0, 0. 1 1. Okay, 1's complement is 1 1 1 0 0. Okay, plus 1. 0 plus 1 is 1 0 1 1 1. So this is your minus m. Yes? Yes or no?
Yes, ma'am.
If m is 3, minus m is 2's complement of m. Right? So after performing this, we have to do a equals to a minus m. So what it will be? What is the a? 0 0 0 0 1, right? Plus 1 1 1 0 1. So 1 1 is 0, carry 1, 0 0 0 0 plus 1 1 1 1 1. So this is your value of a. Okay, so this will be 1 1 1 1 0 and 0 1 1 question mark. Yes.
Yes, ma'am.
Yes,
Now
ma'am.
again, what is the sign bit of a? What is the sign bit of a?
1.
See here. Okay, after performing this, left shift AQ and a equals to a minus 1. Again, we have to check the sign bit of a. If sign bit of a is here, it is 1. If it is 1, what we have to do? We have to place the value of Q0 as 0.
0.
Right? So here we are placing the value of Q0 as 0. So what it will be? 1 1 1 1 0 0 1 1 0. Okay. Yes.
Yes, ma'am.
Now increment the value of n by 1. So what
1.
is n now?
3.
3. Okay. So n is not equal to 0. Then again we have to perform the same step. So what is the step now? See, value of, what is the step? Sign bit of a. Sign bit of a is 1.
1.
So perform left shift AQ, A and Q left shift. So all values will be placed in the left side. Okay, so this will be 1 1 1 0. Here this 0 will be placed here. Then again 1 1 0 and question mark. Okay, so this is your shift left AQ. Yes, after performing this, A equals to A plus M. So what was your A?
1 1 1 0 0.
Yes. 1 second. Your A is now currently your A is 1 1 1 0 0 and your M is 3. That means 0 0 0 1 1. So what it is? 1 1 1 1 1. Yes, so this is your all ones new A. Yes, so you have done A equals to A plus M. Done. Now again check the sign bit of A. What is sign bit of A? 1.
1.
Right? So if sign bit of A is 1, what we have to do? Replace the value of Q0 with 0. Right? So what we are doing? 1, 1, 1, 1, 1. Here 1, 1, 0, 1. We are replacing the value of Q0 with 1. Okay, now decrement the value of N. So this is N is 2 now. Yes, if it is 2, that means N is not equal to 0. Again check the sign bit of A. What is the sign bit of A?
1.
1. So if it is 1, what we have to do? Shift left AQ. So again, this will be 1, 1, 1, 1. Again here 1. Then 1, 0, 1. Okay, and question mark. Shift left AQ. Yes, now add with A with M and store the result in A. So your A is all ones. Q0 is कुछ गलत हुआ क्या यहाँ पे? A equals to A plus M. Check the sign bit of A. Sign bit of A is 1. Okay, so Q0 is 1. Anything went wrong up till now? Can you check? A equals
Yes,
to
ma'am.
A.
Q0 is 0.
Yes.
मैम साइन बिट 1 है तो Q0 0 आएगा ना?
हाँ, sign bit 1 है. Yes, वही तो बोल रही हूँ मैं. Yes, yes. Sign bit is 0. Yes, yes. See, sorry, sign bit is 1, Q0 is 0. So this is 0. Okay. And again, here will be now 0. So your this value will be again 0. Now correct?
Yes, ma'am.
Yes, now we are going correct manner. Okay, shift left AQ. After performing shift left AQ, we are going to check A equals to A plus M. So what is your M now? Initially your M is given 0, 0, 0.
बंद करो रे क्लास तुम्हारी क्या है तो
1, 1 is 0, carry 1. So 1, 1 is 0. Okay, 0 plus 1 is 1. Okay, again 1, 1 is 0, carry 1. 1, 1 is 0, carry 1. Okay, 1 1 is 0, carry 1. Right. So what is your A now? 0 0 0 1 0. Right.
आकांक्षा इकडे जीवन सारंगबरोबर जीवन सारंग माहिती आहे कुठली आहे ते त्याच्या पुढे जीवन
So here we have performed A equals to A plus M. Right, after performing this, again check the sign bit of A. What is the sign bit of A? It is 0.
0.
So we are going to replace the value of Q0 with
1.
Okay, so what it will be now? 0 0 0 1 0 1 0 0 1. Okay, so this we have performed Q0 with 1. Again decrement the value of N by 1. So N is not again 0. So again check the sign bit of A. Sign bit of A is 0. So it is 0, shift left AQ. So this is your 0 0 1 0 1. Okay, 0 0 1 and question mark. So this is you have performed shift left AQ. Yes, after performing this, what we have to go? We have to do A equals to A minus M. So your A is 0 0 1 0 1 plus minus M. Minus M means 2's complement of M. So 1 1 1 0 1. So 1 1 is 0. Carry 1. 0 1 is 1. 1 1 is 0. Carry 1. 1 1 is 0. Carry 1. And 1 1 is 0. Carry 1. Okay, so your new A is 0 0 0 1 0. Okay, and 0 0 1. So you have performed here A equals to A minus M. Right? This is your 0 0 0 1 0. Yes, after performing A equals to A minus M, again you have to check the sign bit of A. What is sign bit of A?
0.
0.
So if it's 0, that means replace the value of Q by
1.
1. Right? So we are replacing the value of Q by 1. So this is 0 0 0 1 0. Right? And 0 0 1 1. Okay, so we are replacing the value of Q0 by 1. Okay, after doing this, decrement the value of N by 1. So it was 1, now it is 0.
0.
Right? So is N equals to 0? Answer is yes. Okay. And check the sign bit of A. What is sign bit of A now?
0.
0.
0.
So if it is 0, then your quotient is in Q. So this is your Q. Yes. That is nothing but 3.
Yes, ma'am.
3 to the base 10. And remainder is in A. So this is your A. Okay, I'm writing here. This is your A, which is nothing but
2.
2, right? 2 to the base 10. Okay, so here you can see in this example, nowhere we have done the restoration method. Okay, can you see this? Nowhere we have performed the restoration method. Instead of that, we have performed, after performing shift left, we have performed A equals to A plus M and then check the sign bit of A. Every time we are checking the sign bit of A and checking the result. Yes, is that okay?
Yes, ma'am.
Yes, ma'am.
So this is how non-restoration is been performed, okay, for division, non-restoring division algorithm. According to the flowchart, you can perform this. If you have any doubt, you can ask. No doubt?
No, ma'am.
No, ma'am.
Okay. You can
No, ma'am.
perform this for example. You can take the example as like 12 divided by 2, the same problem which you have performed by using restoring. Okay, the same problem you can perform by using the non-restoring division algorithm. Okay, 12 divided by 2. Check the result. So, thank you very much. That's all for today's class.